Hello, everyone, and welcome to today's webinar on Champion Challenger experiments. And I apologize for restarting the webinar. We had a few technical issues, and now we're ready to get started again. So thank you for being patient. Your lines are muted for the webinar, so you'll need to use the chat window to ask questions. You can enter the questions in the chat window at any time, and we'll try to address them when you enter them. But we'll also save some time at the end of the presentation for questions. And also you'll notice that there is a mood indicator, a My Mood indicator at the top of your screen. And you can use that to let us know if you're having any technical issues seeing or hearing the presentation. So let's get started. My name is Colleen McClintock, and I'm President of Products for Sparkling Logic. And also Caroline Matignon is with me today, and she is our CEO.
Hi, everyone. Good morning, and welcome to our webinar.
So before we delve into Champion Challenger, I'm going to start with a brief introduction to decision management. And if you don't have a background in decision management and you'd like more details on the topic, you can sign up and attend one of our regularly scheduled product tour webinars. And in that webinar, we cover decision management in a bit more detail. But to give you an introduction, I'm going to start with describing what decision management is and how it works. So in business, we make many decisions and we take actions that are based on those decisions. And decision management is really a practice and a technology that's focused on automating and improving operational business decisions. And by operational decisions, what I mean is the decisions that are part of your day-to-day business operations. And some examples are a bank that has to decide whether or not to approve a mortgage loan, an online retailer who must decide which distribution center they want to use to fulfill an order, which is the best distribution center to fulfill a specific order, and a credit card company that needs to determine the likelihood that a given transaction is fraudulent. So operational decisions are repeatable, recurring decisions, and they're made hundreds of thousands or even hundreds of thousands of times per day. And while these decisions individually may not have much significance to the business, collectively they represent a substantial amount of money and they have a major business impact. So it used to be that people made these decisions on behalf of the business, and it still is the case in some situations like call centers or where you have frontline workers making decisions. But increasingly, these decisions are automated. So it used to be that the underwriter at a bank would decide whether or not to approve a mortgage loan. An order fulfillment clerk might choose the distribution center to use to ship an order. And a fraud specialist might be on the lookout for potentially fraudulent transactions. But as businesses grow and obtain more customers, and as customer expectations continue to rise, it becomes more and more difficult to have humans making these kinds of decisions. And instead, the decisions are automated so that the software can make the decisions on behalf of the business. And this overall is a good thing because computers can make decisions quickly and consistently. And as a result, as consumers, when you apply for a loan, you get an answer in hours or minutes rather than in days. And when you order something from Amazon or your favorite online retailer, you receive your order faster and at a lower shipping cost. And your credit card company might call you if they notice unusual spending patterns on your account to verify that those transactions are actually yours. So the bank and the online retailer and the credit card company are able to operate more efficiently while delivering you better service. But there are some downsides to having software make decisions. So in today's fast-paced world, things change all the time, and businesses need to be able to quickly change the way these operational decisions are made as a response. So, for example, after the mortgage bubble, banks needed to tighten their underwriting policies. And when new distribution centers are added, an online retailer needs to take those centers into account when choose which one to use to fulfill an order. And as new fraud schemes continually arise, credit card companies need to constantly adjust so that they can identify new fraud patterns. So the problem is that when decisions are hard-coded in your software in COBOL and C++ or Java code or whatever language, they're slow and difficult to change. And that's because each change has to go through an entire software development cycle and be implemented, tested, and deployed by the IT department. And this can take weeks and sometimes months. And meanwhile, less than optimal automated decisions are being made, and business opportunities are lost, and customers are dissatisfied. So another problem with automated decisions in traditional systems is that they often take kind of a one-size-fits-all approach to decisions. And every transaction is treated the same way. And you simply offering more choices, more products and product options isn't really enough, because more choices can usually cause confusion and paralysis. So you really have to offer customers the right products at the right time. And even though organizations have a lot of data available about their customers and about their suppliers and their transactions and their employees, that might show them that certain actions are more effective than others, they mostly don't take advantage of this data, and they fail to really leverage it in their automated decisions. And finally, another problem with traditional systems is that they may report or at least provide data that allows you to understand and track the results of those systems, the business results, but there's really not an easy way to improve them over time. So whether a decision is a good one or a bad one is kind of a moving target. A decision to offer your customer, a specific customer, a discount today might be a good decision, but it might not be a good decision tomorrow because your competitors have changed their pricing. So even if we apply business intelligence and analytics to better analyze and understand the data that's generated by these systems, the process to adapt and improve them is too slow, and it's too difficult and costly. So what we really need is a way to come up with and compare alternative approaches and measure the results so that a new strategy can be implemented when it outperforms the existing strategy. And that will be the topic that we'll delve into today. A little bit more about how decision management systems are different from these traditional automated systems that we've been discussing. So decision management systems really overcome these problems because they're designed to put the business in control of the decision logic and to easily accommodate changes without requiring going through the full software development lifecycle. They decouple the decision logic from the system or the application or process so that it can change independently on its own cycle and more frequently in response to changing business conditions and requirements. So another difference is that decision management systems are able to leverage data insight by integrating predictive analytics in order to produce a more targeted decision. And last, decision management systems provide a means to measure results and improve over time. And that's what we're going to focus on in today's topic, champion-challenger experiments. So just to make sure that you have a good picture of what decision management looks like in terms of its components and at the high level how it integrates into your architecture, rather than having programmers define how a decision is made in software code where only they can understand and maintain that decision logic, decision management systems allow business experts to write business rules so that they have direct control over how a decision is made. And the business experts can change the rules or add new rules whenever the requirements dictate, whenever they need to. So more specifically, business experts define the decision logic using business rules and predictive models, and those rules are easy to write and understand. They're transparent and understandable by the business. And the decision logic is stored in a decision repository that not only the team responsible for defining the decisions can access, but all stakeholders on the project, all stakeholders in the project can access that logic and collaborate on the best decision strategy. And ultimately, the decision is deployed into a decision execution service that's invoked by the company's processes and systems. So a decision service isn't an application. It's really a service invoked by processes and applications that contains the decision logic and applies that logic to a given transaction. So decision management systems do more than just automate decisions. They also enable you to improve the decision. And this is important because using decision management systems, you can define KPIs and metrics that measure the business performance of the automated decision. And after you deploy, you can monitor how your decision performs. And based on the decision's impact on the business, you can adjust and improve your decision strategy over time. And this cycle of authoring decision logic and deploying and measuring results and adjusting to improve your decision's performance is ongoing. And this is where Champion Challenger really comes into play. So I'm going to give a specific example to describe Champion Challenger. And the example I'm going to use is for a telecom company. And the specific scenario would be to imagine that we're a telecom company, and we've recently switched to the new way that they do their plans, which is based on shared data and multiple users and multiple devices. So imagine that we've switched to that way of presenting our plans, and our current plans are based on the number of devices and the combined monthly data needs of those devices. And we also take advantage of an opportunity that we have with these new plans to offer customers the ability to upgrade at a reduced price to the next pricing tier as they approach their data limit for the month. So currently, we have an offer to upgrade to the next tier at a 10% discount when a customer reaches 80% of their data allotment. But we might wonder if more customers would accept our offer if it were presented sooner at 70%, or perhaps later at 90% when they're almost at their limit. And we would hypothesize, perhaps, that more customers would accept later because they're more desperate and afraid to go over. So we might want to test and run some simulations to investigate whether this might be an alternative strategy. And imagine that we run simulations, we adjust our decision logic to make the offer later, say at 90%, and we execute against a large sample of our historical data. And from this simulation, we're able to learn how many customers would be eligible for the offer, but we can't learn whether or not they would accept the offer. In order to know that, we have to actually try it in our production environment and present live customers with this new offer at 90% instead of 80%. So imagine that we decide to test this hypothesis, and our current strategy will become the champion, and we'll define two challengers, one to test an earlier offer at 70%, and perhaps one to test this later offer, which we will perform better at 90%. And in order to understand the results, we will have to actually deploy those challengers against some randomly selected subset of our customer portfolio. So this is a way that we can test and learn by doing real live experiments. But Champion Challenger, it's a proven methodology. So in this simple example, I was dealing with just one dimension, so the timing that we made the offer. But there may be other things that we're not so sure about in the way that we're making these offers. So we might have other ideas about how to improve our revenue, perhaps by selling more of these upgrades to the next tier. So, for example, would more customers accept if we gave them a larger discount? And if so, what would be the increase in revenues? And we may also want to understand if specific customer segments would respond to certain offers more than others. So, for example, perhaps customers with a single device plan and customers with single user plans, they might be less likely to respond since they have more control over their usage than the multi-user, multi-device plans. So if you're familiar with A/B testing, which is a fairly well-known and related concept that's used to test either different landing pages or different email campaigns, Champion Challenger is very similar. And in A/B testing, visitors are randomly assigned to different web pages to determine which is the best approach. In this example, you can see that after measuring the results, that version B resulted in 75 signups and version A resulted in 50. So in this case, version B is the better approach. Now, the difference between A/B testing and Champion Challenger is that for A/B testing, traditional way they're used, they're very similar, but for A/B testing, usually you can split who sees page A and who sees page B evenly because both approaches are equally valid, and you don't have really anything to lose by presenting one versus the other. So you're not disrupting your normal operation in any way. And both are equally valid, and it's different with Champion Challenger in that you would already have in place a default approach or a champion that you don't really want to disrupt because you could lose revenue by disrupting it. So you want to keep that champion in place, and you would use one or more challenger approaches that a smaller number of transactions would use. So that's really the only difference between the two. Other than that, they're identical. So with Champion Challenger, let's go into a little bit more detail about how you go about implementing a Champion Challenger approach. So the first thing is really to design your strategy, and in order to design a strategy, you have to first identify some opportunity or problem that you're trying to solve and form a hypothesis. So, for example, in our scenario, we were hypothesizing that higher acceptance rates on our offers would result if we presented those offers later as the customer was approaching their data limit. You also want to make sure that the experiment you're going to perform, your alternative decision strategy that you think will outperform your champion, you want to make sure that it's tied to relevant KPIs and metrics that are somehow reflected, in your profits. So, for example, we might determine that we're going to monitor these decision strategies with the offer acceptance rate and then the impact that they have on total revenue. And then once you've done the first two steps, you need to design your test, and the test needs to be designed in such a way that it will successfully prove or disprove the hypothesis. And you can also determine that you don't want to subject your entire customer portfolio to this test. Instead, you might want to only make the test specific to a certain population. So, for example, from this testing, you might want to make sure that only customers that don't have any late payments, who are able to pay their bills reliably on time, are offered the upgrade with a discount. And the reason you might do that is because even if a non-paying or a late-paying customer is approaching their data limit, well, they're already having trouble paying their bills, so you really wouldn't want to offer them an upgrade for more money, even at a discount. So you need to determine who, if there are any portions of your portfolio that you would want to exclude from your from your experiments or any specific ones that you might want to target for inclusion. And then finally, you want to make sure that you're going to send a small subset of your transactions to the challengers, but you need to have the test running for a long enough period of time, and based on the percentage that you pass through each challenger experiment, you need to make sure you collect enough data that you can ensure that the results are statistically significant. So after you design the strategy, the next step is to implement. And when you implement, you're going to randomly assign transactions or customers, in this case, to your test and your control groups. So your control group, of course, is your champion, and the tests are the however many challengers that you want to assign to. But it needs to be random because you need to make sure that you're not biasing the experiment in any way. So random assignment helps ensure that the populations have the same characteristics as much as possible. And then after you implement, you're going to measure and identify any variation between the tests and control groups. And if one of the challengers outperforms the existing champion, you can promote the challenger to become the new champion. And these activities are ongoing. So it's really a cycle. Every time you promote a challenger to become the new champion, you're going to look at and continue to identify opportunities to improve that decision, design new experiments, implement them, measure, and again, either keep the existing or promote a new challenger to become the champion. And this is how decision management systems have a mechanism that allows you to continually adapt, learn, and improve with your automated decisions. So let's take a look. Let's move on to something that the benefits of champion challenger. I'm sorry, I skipped ahead. I thought I was going to be on a different slide, and then when I changed the slide, I forgot to tell you the benefits. So the benefits, in case they're not obvious, are with a champion challenger approach, you can get visibility into your decision results that you can't easily anticipate. So things like determining whether or not a customer would accept an offer. You can determine what portion of your portfolio would be eligible for the offer, but you can't determine whether or not they would accept it without actually making the offer. So Champion Challenger allows you to do that, and you can even try, and it's common to try several strategies in parallel. And Champion Challenger allows you to reduce the risk of deploying a new strategy because you can first test and prove it on a much smaller portion of your portfolio. You don't have to take a risk and go ahead and deploy a new strategy without first having some legitimate data that gives you a very strong indication that this is going to outperform your current strategy. So those are really the benefits. But let's make this all more concrete. And we're going to give you, Carol Ann's going to give you a specific demo, and we're going to switch domains and talk about auto insurance underwriting now. And in this scenario, instead of looking at opportunities, we're really looking at risk. And we're looking at how can we more successfully eliminate risky drivers from our portfolio. But the problem is basically the same. And what we need to do is, in our case, we're going to be looking at our risk tiering strategy, and our champion that's currently implemented in the system is just based on the age of the drivers, and the mileage. But our challenger will be, we might hypothesize that we should instead determine risk based on the number of accidents. So rather than speculate, we're going to actually demonstrate how you would go about implementing one of these experiments in SMARTS. So Carol Ann, you can take over whenever you want.
Okay, thank you very much, Colleen, for this great introduction. Here I'm actually jumping into SMARTS, And I will spend most of the time showing you how to set up the strategies and how to run the experiment. We are not going to deploy it and wait for a few days or a few weeks to see the results, but the deployment is really very easy once we've done all of these setup. So you may or may not be familiar with SMARTS. If you would like to see how it works and know more about the product, we encourage you to come and attend one of our product tours or to contact us. We would be happy to give you a one-on-one demonstration of the product. To give you some orientation about the product, about SMARTS, I'm actually running out of the cloud into my browser, and I have access to a number of projects. And I want to remind you that none of these projects or none of this environment has been customized for my specific project. So what you see right now is really the product out of the box. So I'm going to jump into this Insider webinar, project where I created this AutoQuote project. So let me jump into the decision. And now in my work area, what I can see is obviously the business rules, and they are available here on the bottom right side of the user interface. But you can see also a lot more context that help the user, the rules writer, to really understand what's the impact of the business rules directly onto data. And there are two different views for that. One is looking at transactions one by one. So on the left side, I have a document pane that shows me 100 different transactions, and I can see for each one of them what the data looks like for making the decision, but I can also look at the decision that is made by the rules. So let me collapse and focus on the decision outcome. You can see that some of our applicants have been referred. Let me move on to show you some that may have been approved. So you can see all the different decisions that were made by SMARTS one by one, and looking at the premiums and the risk level that was assigned to each one of these transactions. On the right side, we do have also another view on data, and this time it's based on aggregate. So I can see distribution reports, so I can see some other charts that give me some insight as to what the data looks like as an input, or what is the effect of the business rules, again, in aggregation. So let me focus right now on the risk level. So when Colleen was talking about our experiment for today, we are looking at the current way we're doing risk assignment based on the age of the drives and the total mileage that they reported. But I would like to maybe experiment and see if there is a better way to assign risk level based on some other information that is provided out of the system. So in order to do that, I'm going to swap my business rules and my documents. As I'm setting up the rules and as I'm setting up the experiment, I'm not focusing so much on the documents and the transactions one by one, but I would like to see where it will fit in the overall decision strategy. So I'm going to swap the two panes. There you go. And I'm actually going to remove everything that is related to the data so that we can look at our decision flow. The decision flow is the way that all of the business rules that are available in the different rule sets are orchestrated. So when a transaction comes in and I need to underwrite it, I will make sure that all of the data is there and that it looks good. And if it's there, I may want to augment it with some calculations. But eventually, I will apply some knockout or rejection rules to find some red flags. Maybe I don't want those drivers with a lot of accidents, or there might be some other aspects that I do not want to cover. And then if everything looks good, then we will proceed with a tier assessment. And tier assessment is really where we're going to do our experimentation today. And eventually, based on the tier that this driver or this policy falls into, there will be a rating that will be computed. So we'll compute the premium and eventually issue the quote. If anything goes bad, then we'll go into a referral or rejection activity on the right. But let's focus on this tier assessment. So when I expand this decision step, I can see some information. But what I'm really focused on right now is setting up alternatives. So let me just slide up a tiny bit so that you can see the rules at the bottom. So now I can see my high-risk rules, which is the way that we make decisions today based on average age. And if I scroll down, I will see more of these business rules. What I would like to do is to create an alternative. So I will have another rule set in my system. And this one is going to be a brand new alternative. If I had already created my rule set, I will be able to select it. If I wanted to derive from somebody else's rule set, maybe one that was defined nationwide, and I want to have to create a local exception, I would use our derivation mechanism. But today I'm just going to create a new tier assessment. Let's make sure I don't do typo. And this one will be based on accidents. There you go. And, in a real life system, I will provide a description. But for the sake of time, I will just create this brand new decision step that will contain my rule set. And that's all I need to do. If I add more alternatives, I will be able to keep adding some. The only thing I will do is to add maybe I can refer to this challenger. So this one is my challenger that is based on the number of accidents. Eventually, I could have another challenger that is based on some other metric, but let's focus on that. So as part of my decision flow, now I have an alternative. Some of the transactions will come through my tier assessment that is traditionally defined based on the average age and mileage, but I would like some of the other transactions to go down a different path. This is the level of granularity that I have chosen for this experiment. You may decide to run your experiment at a completely different level. For example, you may want to have two different implementations for the entire decision. So you may want to just derive the decision, start making tweaks, and compare how they work. Because of all of my changes were located in that one activity, I decided to do it at the decision step level. But you may also want to run an experiment where you're just creating different flavors of a single rule. So you can really decide what's your level of granularity. So once you've identified and created your alternatives into the decision flow, it's time to write the logic. Our rule set based on the number of accidents has not been filled in yet. So I'm going to go back to our business rules, and let me collapse so that we can see all of our decision steps that are available into the system. And I will be focusing on this one that is based on the number of accidents. And you can see that my rule set right now is empty. So for the sake of time, I could be writing the rules by hand, but just for the sake of time, I'm going to swap the two panes, and I'm going to use red pen to create my business rules. So when I use red pen, I have the opportunity to just click on this rule set to say this is where I want to create business rules. And now I can select the conditions all graphically. So I said I was interested in the number of accidents. So let's have a rule for those that have very few accidents. Actually, instead of one, I will be focusing on those that have 0 accidents, and that will be the low end of the spectrum in terms of number of accidents. So it's the best risk. So for my drivers that have 0 accidents, I would like my risk level to be low risk. And when I click on the various parts of the form using red pen, this is creating automatically some new conditions in my business rules. And actually, I should probably show you the rules so that you can see there is no magic. So my rule has been created for the maximum number of accidents and the risk level being low risk. But we don't want low risk to be a condition. We want it to be an action. So I'm going to use the sticker to relocate and say I would like to turn it into an action, and it will turn blue, which is our color coding for actions. And let me change the name to say this one is going to be low risk. Now I would like to create another rule for those that are medium risk. And I could do the same thing and just go step by step. Instead, I'm just going to enter this plus mode in red pen that allows me to create an exception. And now I'm going to say that it's going to be for those number of accidents that are between 1 and 2. So if the number of accidents is between 1 and 2, which is true right now because we have 1, then I would like the risk level to be medium risk. So I just have to edit. And you can see that a new exception rule, let me actually expand so that you can see better. You can see that a new rule has been created here. And I will just change the name because I like the name of my rules to be representative. I would say medium risk. And now I can create yet another exception. And this is going to be for those that have more than 3 accidents. So let me scroll down, greater or equal to 3. And those will be high risk. There you go. And I will just change the name. The name is automatically computed based on what I click first as a change. But there you go. So now we have created this new tier assessment rule set, and this is the one that we would like to experiment with. I've defined where I would like the experiment to take place, but I didn't actually set up the experiment. So we will move into our dashboard area where we can review the report and we can set up this experiment. Just a note on the way I created the rule. I love red pen and I find it very intuitive and very quick to create all of these different flavors. If you're more traditional and you like to write the syntax or you prefer decision tree or decision table, you can just turn any of these rule sets into the representation that makes sense for you or that you like the best and use that, of course, so you don't have to use red pen. So let's go to our experiment now. One thing that you may or may not have noticed here at the bottom is that I have a section for experimentation, and this section is actually supporting the experiment in a way that it will define which transaction is going to go right and which one is going to go left in our experiment, which one will be in the control group and which one will be in our test group. So there are 3 fields that we need to set up, and that's just a one-time activity. You don't need to do it every time. You just need to do it originally. The first one is more about the mechanics of how it works. It's our random digit generator, and this one, in our case, we're just using a random function to be able to generate those random digits. I've seen different strategies where people wanted to extract the random digits from some details of the date or something like that. So you can really pick whatever you would like in your system, but something that will work in terms of being statistically relevant is to pick this random function. And then our champion challenger module is going to leverage this random digit to assign a generated random digit to this specific transaction. So when I move to another transaction, you're going to see that each one of them have a different number. And then I will capture the chosen strategy. And the reason I'm doing that is so that I can report and I can know which one is the set of rules that applied to this specific transaction. So all of that, after adding it into my form, will be leveraged as part of the experimentation. So actually, I'm going to make the rules disappear, and I will be focusing on our experimentation now. So part of our experiment are some details, just as always, name, description, and the social bar that will give you access to the history of this experiment and the tags and discussions, all the social information related to it. The second tab is this configuration that will just identify which one is the random digit generator that we use, which one is the generated random digit field in which the system is going to store the value, and which one is the chosen strategy. And you can see here all the selection that I've made. And finally, I will go into the strategy where I will be able to define how I want to execute. So even though you might define an experiment, you may not be ready to deploy it. So you do have a choice as to what is the strategy that you want to execute. In our case, I've selected Champion Challenger because that's what I'm demonstrating today. So every time I execute, when I click on the Run button or when I deploy it, the system will know that it will route the transactions to either the champion or one of the challengers, and I have only one today. I could also decide that I don't want to do the experiment, so everything will go through the champion, and that might be if I wanted to stop the experiment for some reason. And then eventually I can select the alternatives. We define the alternatives in the flow, but it doesn't mean that we're going to pick them. I might have defined alternatives in 5 different decision steps. Now is the time to select which one I would like to actually activate. So when I expand, I can see that we did only one, and it was in this tier assessment decision step. So that's what I will be selecting. And now I'm ready to look at all the different options. So I'm going to generate all the different strategies. I'm going to create all the default strategies just by introspecting this tier assessment activity in the flow and look at all the different alternatives that have been defined, and it will assign equal amount of transactions going through each one of them. If you had a lot more options and very few of them makes sense, and you want to pick that rule set A has to work with rule set B but not C, you would be able to pick and choose what are all the combinations that make sense just by adding them by hand over here. But let's go with the easy path of defining what's the champion and what is the challenger in our experiment. So you can see that the names have been reported based on what I had entered before, and the percentages are equal. I actually would like to change those percentages to be 80-20 for some reason. Maybe I would like to do that because I don't want to take a chance. I know that this strategy, this challenger, is controversial. So maybe I want to experiment first with 5%, and then 10, and then 20. And if it works well, I'll go up to 80, and I'll start introducing another one. So this mechanism, this infrastructure for Champion Challenger can be used for really testing, which is the true value. But you could also leverage this mechanism if you wanted to use it for rolling out your deployment and shifting from version 1 to version 2 and just increasing the number of transactions that goes into the new strategy. So that's all we really need to do at that point in time for our strategy. So we've defined everything. Now we're ready to run the strategy and review the reports. The reports that I have when I switch back to the dashboard are based on the age group and the decision outcome. I have my transactions being approved, referred, or denied. Because my experiment is about the number of the tier assessment. Instead, I will additionally, I would like to report on the risk level. In order to create a new report in Smart, you just drag and drop your field into the dashboard area. And now we do have this new report that has been added. Let me expand it. And you can see that for this current run, we have 9% of them are high risk and 11% are low risk, and I have 27% of them that don't have a risk level, probably because they have been declined or the application was invalid in that case. And eventually 53%, the vast majority, is standard risk. So I'm ready to run my strategy so that I can see how well it goes. So I can just run the execution. And actually, one thing that it's telling me is that, so it is giving me the new report, but the one thing that is missing is the traceability to know which one I've been assigned because of the champion and which one I've been assigned because of the challenger. So in order to add this information, to be able to drill down into each one of them, what I need to do is to just define this chosen strategy as being a metric. So I will define it as being a KPI, and there's nothing else involved in clicking on this button. Now I'm able to run again. And looking at this report, what I would like to do is to introduce this information. So I'm going to go under the hood behind the report to see all of the information that is available. And actually, just for the sake of space, of real estate, I'm going to swap those two panes, and we're going to be focusing on this table. So let me swap, and I will take all of the real estate. So you can see this big table has a lot of information for all the KPIs that we have been tracking. But what I would like to do is to just, I think I saw my strategies. Where are they? They are here at the very end. So I'm going to select this chosen strategy field, and I'm going to say I would like to report based on this chosen strategy. And I can decide where I would like to introduce it as a different axis, and that will change the rendering on the other side. So here I've added chosen strategy as a dimension to my report. I can go back to the chart, and now I can see that this is my challenger and this is my champion. I can see all the different values for the different risk levels for the buckets. Another way of representing it, let me just look at the properties of the report. It would actually be nice to see all of these bars being stacked so that I can compare my challenger to my champion, and I can see the size of all the different segments. Because I said I only wanted 20% of the transactions to go down my challenger, those do not really compare very nicely. So what I can do instead is to look at the stacked 100, and this one is just going to represent based on percentage instead of representing based on value. I can still see the number of transactions in the end that were assigned to each one of the segments. If I wanted to see the percentages, I will have to play with more options here to display percentages. But let's say I do like the report as it is, and it allows me to compare and to decide eventually which one is the report that I like. Of course, everything that I've done so far is only in the development environment. So the same way that Colleen was talking about the fact that when we know what we're recommending as an action, doesn't mean that people are doing it. So if we proposed the 90% plan or the 70 or the upgrade at 90% or at 70%, it doesn't mean that we know exactly how many people will take it at that point in time. So the next step is to take this whole strategy, including the experiment, and to push it into a deployment so that it can be tested live. All of that is absolutely no different than deploying a normal decision service that doesn't have an experiment. So all this plumbing that does the routing of the transaction is what comes out of the box as part of this champion challenger capability in the deployment. And then it's up to you to really track the performance, which might be how many times did I promote it. And then down the road, you really want to track how many times did people take the offer, or what is the level of claims that I got for my insurance application down the road, etc. So it's not just the raw outcome as to what did you decide, but it's really what is the impact of your decisions, so that you can take these reports and eventually bring them back and promote and introduce more variations and keep experimenting. As we said, it's really all about experimentation and continuous improvement, so that you can always be on your toes and tweak your strategies to find the best one. So hopefully there was not too much information at once. Hopefully this was an interesting topic. I would like to go back to the slides very briefly so that we can take a couple of questions. I think we have 5 minutes left on our presentation. So, Colleen, do we have questions? And I should mention that the way you can ask questions, since your lines have been muted, is by using the chat window. So through the chat, you can let us know if you do have questions, and we will be taking them. If for some reason you prefer your question to remain anonymous and you would not want this question to be asked on the floor, just let us know in the chat, and we will answer these questions privately by email after the presentation. So, Colleen, do we have any questions?
We do have one question, Carol Ann, and the question is, how do we avoid confusing customers? So how do we avoid presenting an offer at 70%, 80%, and 90% to the same customer?
Oh, that's an excellent question. Of course, one of the benefits of decision management is consistency. By making a consistent decision, you can increase customer satisfaction and make sure that you have a consistent behavior for your customers, whether they call the call center, whether they go online, or whether they stop in a branch. So introducing this champion challenger that will randomly send the transactions to a champion or a challenger is going against that idea of a consistent behavior. The way we deal with that is actually very simple. It's based on this random digit or the mechanism that we use to assign the strategies. So typically, once you've assigned a strategy and you say that Joe, for example, our typical first applicant in this data set, has been assigned a very aggressive or the challenger strategy, you want to make sure that you retain this information so that the next day, if he comes back or if he goes online and checks the benefits, it will consistently be part of this segment. And this is really important, not only for customer satisfaction and the way you present to your customers, but it's also extremely important in some industries that are regulated. For mortgage, for example, you are not allowed, and that's a federal mandate, that you are not allowed to change the way you process the applications midway in the process. So if you started with a challenger, you have to finish with a challenger, even though it might be up to 30 days later when you finally have all the documentation to process a loan. So this is really a critical aspect, and of course, this has been baked into the way that Champion Challenger works. That's a great question.
Okay, we don't have any more questions, so I think we can quickly summarize. And what we saw today is and learned about is how Champion Challenger experiments can allow you to test ideas that improve your current decision strategy while reducing the risk of actually deploying that strategy wholeheartedly into production, just allowing you to experiment with some subset of your total population to determine and project what the results would be if you were to deploy that as your champion. And Champion Challenger also allows you to continuously refine and improve your decision strategy in order to produce better business results. So setting up this Champion Challenger strategy is actually quite easy. The hard part is making sure that your tests are the right tests and that you have the proper business objectives defined. But the actual setting up and establishing the test itself and deploying it into production is all built into SMARTS, and SMARTS is the only decision management system that really provides out-of-the-box support for these Champion Challenger experiments. So with that, I'd like to just conclude by inviting you to learn more. And the best way to learn more about SMARTS is to sign up for a free trial SMARTS evaluation so that you can start to manage your own decisions and learn firsthand how SMARTS works. So if you're interested in a trial, please sign up on our website. We also provide additional information on decision management topics in our blog, and we have a regular newsletter that we send out that announces things in the decision management industry and related industries, and also talks about new enhancements coming in the product. And you're welcome to sign up for the newsletter or attend one of our future webinars. So thank you very much for coming today. We appreciate your time, and we hope to see you at a future webinar or see you as a new trial user. So thanks very much.
Thank you very much, and have a wonderful day.